Hey folks, I'm Saeed, the Codogrammer, and in this video we're going to look at a newish feature of Java called records. So let's jump straight into it. Alright, so here we are inside a Java project in IntelliJ. So let me just minimize this to get it out of the way. So before we talk about records, let's try and understand exactly the problem that they were introduced to solve. So let's have a look at another class called person. Now this is just a very simple data class. It's got a couple of fields, name and age. They're both final. And this is just a data holder, which doesn't allow you to change any of the values. There's no setters on here. There's just getters. It's got a constructor. It's got a toString method. It's got an equals and a hash code. So there's quite a lot of code there for something that really only has a couple of values. It's a lot of boilerplate for something that's so seemingly simple. It's so simple, in fact, that a lot of this kind of code can be generated by IDEs by going to somewhere like here and generating these methods. But the big problem with generated code is that it doesn't auto update. So for example, we've got this toString method here with name and age. If I was to add a field here called, let's try private final, address, for example. Okay, we already get errors because it's final and it's not added to the constructor, but ignore that for a second. You can see that the toString field hasn't been updated for address. The constructor hasn't been updated for address. So generating code from your IDE is a very handy solution, but it doesn't fully solve the problem. So let's get rid of that. All right, so looking at this class, hopefully you can see the amount of boilerplate that's required for a very simple object that's really only holding two values. All right, so let's jump back to our previous class. So records were introduced and are one solution to this boilerplate problem. So let's have a look at an example. So here we've declared a house record with this record keyword, and it has two fields, address and number of bedrooms. And we just declare the curly braces here. And that's all that we need to be equivalent to this effectively. So all of this code is now equivalent to this just using the record keyword. All right, so let's dig in a little bit deeper. So records were introduced in Java 14 as a preview feature. So you can only access them if you enabled preview features. Then they were introduced for real in Java 16. So if you're using Java 16 and upwards, you can play comfortably with records. Records are, broadly speaking, immutable data classes. Only the class name and the field types have to be provided. The fields are automatically final and private. A constructor is created for you automatically. You get equals hash code toString. These methods are automatically provided with sensible implementations. Getters are automatically generated, except that they don't use the get prefix, which you're probably used to seeing with Java beans. And records are final, so you can't extend your records. All right, so let's have a look at constructing instances of records. So here we have a var person equals new person record. Person record is, as the name suggests, a record. And we pass in the values to the constructor as we do with all the Java objects that we've always done. Okay, nothing unusual there. Now, if you want to access any of the fields, you get a method name corresponding to the variable name without the get prefix. So .name accesses the name, .age accesses the age provided by default. Now, what if we want to pass in only some of the values? So let's try passing in no values. And remember, person record has two input parameters, name and age. So let's try that. And we get an error message saying that expected two arguments but found none. So you can't not pass those values in. Now let's try passing in null for one of the values. And it looks like that's perfectly acceptable. So in this case, the name would be set to null. Probably not a very good idea, but technically legal. All right, so we've already talked about the problems of using auto-generated code by the IDEs, which is that it doesn't update. So if you add and remove fields from your object, it doesn't go and automatically update your toString, your equals and hash code. But there is an alternative to generated code, which is a tool called Lombok. And we have the question of, well, if we can use Lombok, doesn't it make records pointless? So let's talk a little bit about what Lombok is and how Lombok compares. So let's just jump to this class here, which is a person with Lombok. So first and foremost, what is Lombok? Lombok is an annotation-based library for Java. It produces bytecode, not actual code, from annotations that you add to your code. So you just add annotations, and behind the scenes, it creates a bunch of bytecode, which would otherwise be ugly boilerplate. All right, so let's have a look at an example here. So we've got a person. We've called it person with Lombok for the sake of this lesson. And again, this has got a name and an age. And if you look here, there's no other real boilerplate. The only thing we've got is the @value class, which declares it as a kind of read-only data carrier. Now with the @value annotation, you get an equals method, you get a hash code method, you get a toString method, you get getters, and you get a constructor, all for free. So that's as simple as declaring the @value annotation, and otherwise the class looks like any other Java bean. All right, so I think you'll agree that it's pretty great in terms of how it can simplify your class and reduce your boilerplate. The other big advantage over Lombok over generated code is that it auto updates. So if I add a field to this class or remove a field, I don't need to remember to update my toString or my hash code method. It's taken care of automatically. So that's a big win over IDE generated code. But it's not a completely free lunch because you do need to pull in an additional dependency for Lombok to work. You'll also need an IDE plugin for it to work. So the question is, does Lombok really have any advantages advantages over records? We can see that it has advantages over generated code, but what about records? Well, you have a little bit more control over things with Lombok. For example, you can hide certain fields. You can control how an instance is created using a builder or a static factory method. So do records have any advantages over Lombok? Well, the first big thing is that they are baked into the language, so you don't have any external requirements. The other thing is that there are slightly fewer lines of code. You can often declare a record on one line. So I think you'll agree that despite code generation and despite Lombok, records are still an excellent feature. So let's go back to our main class. All right, so the next thing to look at is generics. Can you use generics with records? And we've got an example here where we're not using generics. We've got another example here where we have a type T declared on the record class, and we can use that T here as one of the values that's being passed to this record, and that's absolutely fine. So yes, you can use generics. Records can also be declared inside a method, just like you can with a class, so no difference there. Records can also implement interfaces. So here we've got an example of implementing two different interfaces, and they can do that just like a normal class can, but they cannot extend anything, abstract or not. They can't extend another class. Now this is because they implicitly extend java.lang.record. You can't see it, but under the hood, they do indeed extend record. Okay, and that's this class here. Okay, just get rid of that. So that's that, and obviously you just provide your implementation. All right, so you can also declare a record with no parameters. So you've got a type here called B, and you've given it no properties whatsoever, which is a bit strange because these are kind of considered data carriers, and this data carrier doesn't seem to have any actual data. But if you can find a use case for it, then at least you know that you can do that now. Now, the other key thing about records is the constructors. A constructor is provided by default that takes all of the arguments just by declaring the record class itself. You can override that. And if you do, you don't need a parameter declaration for each field. You can if you want to. If you do, it's a canonical constructor. So if you provide the parameter list, it's a canonical constructor. If you don't, it's a compact constructor. So compact constructors are something that came in with records. You don't need to assign the fields. That's also done automatically, but not done automatically in canonical constructors. So let's take a look at what that means in practice. So we've got a compact constructor here. We don't declare the argument list here because it's already here. Okay, and this is the new compact constructor syntax. And we might want to declare something like this because we've got some extra validation that we want to put in or do some kind of other processing, which I generally keep to a minimum. Now, why would we do something like this? It may be because you want to introduce some validation, like we've got an example here, or you want to do some other kind of processing before actually constructing the object. And if you notice here, we're not assigning any fields. We're not saying this.engine equals engine because we don't need to do that. All right. Now imagine we want to create a constructor with much fewer parameters because we want to hard code. In some cases, we just know the engine and we want to hard code the number of wheels to 4 because it defaults to 4 for whatever reason. You can create a constructor like that, which is absolutely fine. We can also create a canonical constructor. So let's just uncomment that. Now you see that we get an error message. So let's just see what that says. Is already defined because we've got this constructor here. So this effectively defines the same signature as this one here. So let's just comment this out for a second. Okay, and so now here we've declared the parameters and therefore it's a canonical constructor. In this case, you have to assign the fields yourself. So I can't really see a huge reason why you'd want to do this, but you can if you want to. And one final use case might be to declare extra parameters, which aren't actually fields on the record class, which you could do. I can't really, again, see much of a point of it, but you can do that if you want to. Now, the next question is, can we override any of the default methods that are provided, like toString equals, etc.? The answer is yes, we can. So for example, if you wanted to customize how this looks because you wanted some extra characters in there, you can just override the method and do that yourself. We've already talked about the fact that records are immutable. They're not really actually immutable because that's a much wider concept and topic. But to keep things very simple in this tutorial, it's good to think of them as immutable. You can't change the values. So let's see if we can't change the value from outside. Can we change the value from inside? So let's try that. Can we assign the field to a value? No, we can't. All right, so let's comment that out. So that shows you that you can't change the bury value internally. What if we want to access the value from outside and set it? Can we do that? And in this case, this compiles because we've declared this method here, okay? But in this method, we can't actually set the value. So let's just comment that out to make our example a bit clearer. There is no set bury method, so we can't do that. Let's try the bury method. And there's no bury method that takes a parameter. Again, there's no way to actually set the value externally. Let's see if we can access the value as a field. So if we say fruit dot, let's say, and we can see the field in this context, but we can't set the value to anything because it's final. So hopefully that makes it clear that you can't reassign that field from outside. All right, so next up, let's have a look at static methods. and fields. So you can see that you've got a static final field here, which is effectively a constant. You've got another static field here, which isn't final. And again, no issues with compiling that. We've also got a static method, which can be accessed the same way you access static methods on any Java class with using the actual class name. So in this case, you'd say y.add, and that would be absolutely fine. Now imagine you've declared a record and you want to add instance fields for whatever reason. You don't want to declare them here, you just want to add them internally. Can you do that? Let's try it. And no, we can't. Instance fields are not allowed in a record, so they have to be declared up here. Now you may have wanted to do that because you don't want to declare it as part of this constructor here for some reason, and you just want to hold that value internally, but unfortunately you can't. Okay, so let's just comment that out. Can you have instance methods? Okay, you've seen here that you can't have instance fields other than the ones declared up here. Can you have instance methods? Yes, you absolutely can. You can declare them. You can declare as many of them as you want and just use them as you would in a normal class. All right, so I hope that was useful. Don't forget to subscribe for more tech tutorials and industry news, and thank you for watching.